Hello everybody. Today's lecture is going to be on assessment in mathematics instruction, and let's just get right into it. Let's talk a little bit about what assessment is, and specifically what is assessment in education. Assessment is just the process of gathering evidence about a student's knowledge, ability to use, or disposition towards mathematics, and then making inferences from that evidence for several different purposes. In education, we assess constructs. Constructs are hypothetical attributes that people generally believe to exist. An example of a construct in everyday life would be the construct of depression or the construct of happiness. Most people agree that those constructs exist. But where do they exist? They exist in the mind. Could even argue that they exist in the heart or the soul. But generally, biologically, it's the general acceptance that it is our mind that is affected with emotions, specifically things like depression or happiness. In order to measure happiness or depression, something that exists inside your head and you cannot actually see with your own eyes, you can only rely on behaviors that a person exhibits. And usually, not only one behavior will be enough for there to be sufficient evidence that a construct exists. So for example, if you were measuring something like depression, and you said, well, somebody is depressed if they cry. Is it enough to have just one symptom in order to diagnose depression? Perhaps you're looking at someone that doesn't eat, stopped eating. That could also be depression. There are various reasons why somebody might stop eating, not just depression. When people are looking to diagnose something like this, they're looking for a variety of factors to convene in order for there to be sufficient evidence that that construct, the construct of depression in this example, exists. The same thing in mathematics. What we aim to measure is the construct of mathematics achievement. We need to look for behaviors that are aligned with that construct, mathematics achievement, to be certain that that construct exists, because we cannot see it. We can't crack open a little kid's head to see how much math achievement is in there. The only way we can measure it is if we have students engage in behaviors that are aligned with the construct of math achievement and then evaluate that behavior. When we are assessing, we have to operationalize that behavior ahead of time so we know what to look for. In that way, I can say I decided ahead of time that a kindergartner can add if I give them 2 single-digit numbers and they use cubes to find the sum. They use cubes to find the sum, and they find the sum by counting up the total number of cubes. That operationalized objective is evidence that the construct exists. So as we assess, we have to keep in mind what are the objectives that we are trying to meet that would be considered sufficient evidence for there to be a clear indication that that construct of math achievement exists. So what do we assess in math? Well, in math, as we already talked about several times, we go back to the adding it up document where they said that in order for someone to be truly proficient in mathematics, they would have conceptual understanding and procedural fluency. They would have strategic competence and adaptive reasoning. And then the one that I keep pushing off to another video, hopefully, is productive disposition. Those are the things that we are aiming to measure to determine if a student is numerically powerful or numerically proficient. I don't want to get too much into the role of assessment in this video. I really want to just focus on types of math assessment and what to kind of look for. assessment is a whole class unto itself, and I can link my videos on assessment to this one. I'll see if I can also put it in a card as soon as I am able to upload them. And then that way, when you have to worry about actual assessment, you have a resource. But for this class, I just want to briefly go over a couple points as we move forward. Assessment objectives, assessment goals, may or may not be the same as instructional goals. They're not an aim. They're not a standard. They are actually defining what will be measured. An abstract goal is a very general term. You use words that are very vague and are not measurable, like know, understand, learn. Those things cannot be operationally defined in behaviors. Here are some examples. These are abstract goals: to know your multiplication facts, to use a ruler, to analyze the plausibility of an answer, to express mathematical concept abstractly. These verbs are too vague and they cannot be considered evidence of learning. In other words, they cannot be measured. I cannot see a use. What does that mean? I cannot see know. I have to have evidence. I have to have very tangible evidence that these things exist in order for me to evaluate a student. So what do well-written learning objectives that are standards-based look like? Specific instructional objectives for assessment have 5 criteria, and really 4 of them are the ones that you absolutely have. The last one, the criterion, in my opinion, I don't recommend using it because it just it's hard to maintain. It's hard to address the criterion. Let me show you what this is. The audience is a teacher's instructional objective, and it's aimed at the student. So if you are a teacher, your audience will always be the student. The performance component is the measurable behavior that indicates the attainment of the goal. So it would be things like calculate, add, find a product, find a common denominator. Those are all measurable verbs. Cross multiply, things like that, they're all measurable verbs. The content is the general part of the domain that the behavior is focused on. So it might be multiplication, it might be division, right? It's a general part of the domain. And the condition is the context that stimulates the performance. So what is the impetus for the student? What is the raw material that the student is given that will prompt them to engage in this activity so that you can measure it? So here is a graph, and I've gone ahead and put in 4 examples of math objectives. So all of these are the conditions, all these are the audience, all these are the performance, this is the content, and I only did the criterion once. This is how you read it from left to right. Given 3 add-ins, the student will add with regrouping by using base 10 blocks. Here is what the student is given, that's the impetus. Notice all of these say student because that is the target. What are they going to be doing? They're going to be adding with regrouping. Okay, you can actually see some of the adding with regrouping. And they're going to do this using base 10 blocks. Here's another one. Given a scenario that requires division and multiplication, the student, right, always the student for the audience, will apply the order of operations by using a polio strategy of their choice. So you're looking for them to apply order of operations through this method. Given a list of numbers, the student will identify odd numbers by creating rectangles with square tiles. We did this one in an earlier lecture, in one of the earlier videos that I created. We looked at how we can do a CRA lesson by giving students tiles and having them find the rectangles and then having them draw them out in graph paper, etc., so that they are able to identify odd numbers through this. This is the last one. Given 2 factors, the student will find the product by using arrays. So the students are given 2 numbers to multiply, they will find the product, and the teacher wants to them to do this by using arrays. These 4 parts, the condition, audience, performance, and content, are necessary for an instructional objective. The one thing that is optional, and I would, unless your school wants you to use it, I would stay away from it completely, is the criterion. And that would be something like 9 out of 10 times correctly, or with 90% accuracy. Briefly, what I can tell you about the criterion is, unless you aim to do something where the students are continuously meeting this criteria, it can get very messy and cumbersome to try to keep track of what skills or tasks they have not been able to meet the criteria at the level for. And it's hard to balance it in how many times are you going to have students do the same type of work for you to have enough evidence that they can do so. So we've talked about what assessment is, what we need to assess, and how we will know if we're assessing it. Let's now talk about the different kinds of assessments and different purposes for assessments. So there are 2 major categories that assessments can fall into. Summative assessments, which are just for reporting or summarizing achievement, and formative assessments, which are meant to improve instruction and learning for learning as learning. The category in which your assessment will fall into depends on what you want to do with the results. Let's first speak about summative assessment. So summative assessments are the ones that you typically think about, right? First come to mind when you think about assessments in math class. They are generally things like quizzes, end of chapter exams, midterms, finals. Sometimes they can be homework scores, sometimes they can be exit slips even, or do nows. They might also include the state tests, which are usually taken around April or May. For a long time, the DOE had these tests called the acuity tests, and those tests would take place either in November or December, something like this. These types of summative assessments are used to assign grades or marks, and they reflect how well the student is doing in the course. It communicates that to the student, the parent, administrators, and depending on what grade you teach, it could communicate it to guidance counselors or colleges, whatever. Summative assessments are usually given at the end of a time period that they intend to measure some level of achievement. So you would generally have a summative assessment at the end of a chapter because you just finished working with the information that was within that chapter. Parents love summative assessments because they're very familiar to them. When they look back on their experiences in math courses, it was not uncommon for them to take a math test and maybe take it home so that the parent could sign it. And that's what they're expecting their students to have. They're expecting traditional pencil paper tests. Summative assessments are essential to a point, right? You have to be able to explain to parents or administrators how you calculated a student's mark. When thinking about math assessments, you have to consider how well you designed the task, because each item or task that you use for summative assessment should allow some valid inference on how well the students met your instructional objectives that we just discussed. This test item right here, supposing this is a test item, it should be the vehicle or the lens where a teacher can actually assess the student's true achievement. Without carefully constructing your test items, there are a number of factors that can cloud your inference about a student's achievement. One is a strategic opportunity. So I'm just going to use multiple choice as an example here. If you have 4 possibilities for a multiple choice question, you have a 25% chance of getting the answer correct if you were just guessing. Consider a situation where you had a multiple choice question and one of the possibilities was just completely ridiculous. There's no way that was going to be the answer. Now you have a strategic opportunity. You have now increased the odds of getting the answer correct by about 8%. So now instead of having a 25% chance of getting the answer correct, now you have a 33%, 0.333, whatever, chance of getting the answer correct. If you can eliminate two of them, if two of the possibilities are ridiculous, then now you have a 50% chance of getting that answer correct. So the student was able to take advantage of a strategic opportunity to show you that they knew. So when you interpret the student's work, it would appear that they knew the answer, but really they took advantage of a strategic opportunity. So your inference about their knowledge is clouded. It's not valid. Another thing that can happen is a test item can actually block your assessment of their knowledge. So if you think back to any tests that you might have taken where you weren't really sure what they were asking, like there's something about that question that seemed odd, and then later after you got your test back and the teacher explained, well, this is what I meant, and you thought to yourself, well, duh, the answer is B, but I didn't know that's what she was asking. If the test item had been more clear, then certainly I would have gotten the right answer. So that test item was blocking your teacher's inference about your actual knowledge. So the test item is really asking the student to exhibit the behavior that you have defined as being an indication of math achievement. If that test item is faulty, you cannot make a correct evaluation. You cannot correctly assess the student's construct. So being very, very careful when you're constructing test items is important when you're working with mathematics for summative assessments. I do want to offer you a resource for really good, well-made items that are aligned with the Common Core State Standards, and they are actual sample problems from standardized tests. These two links that you can access through the Google Slides and you can also access in the description box will take you directly to the PARCC assessment site and to the Smarter Balance Consortium site. Both of these organizations create test items for the national standardized tests. So they're absolutely great to look at. You can get an idea of how test items are addressing the standards, to what depth, how are they, what do they look like in the progressions, etc. And as you kind of start to look at all these pieces, you can get a very clear idea of what's expected of your students. Always go in, look at your resources that the school is having you use, whatever adoption that you guys are using in your classroom, and compare it to what organizations that create the tests are offering to make sure that everything is aligned. The type of assessment teachers are most likely to use are formative assessment. And formative assessments are assessments that are created to inform the teacher and the students so that misconceptions are cleared up, so that the student can recalibrate their understanding of the material, so students can accommodate, so students can assimilate knowledge. The purpose of a formative assessment is not to evaluate the student, it's really just to evaluate the process and to try to improve a student's understanding of the topic. Now, a summative assessment can also be formative. If you were to take last week's chapter tests and you looked at it and you thought, well, Thomas really needs to review long division with decimals because he's getting this part confused. So I'm going to go ahead and use this test to make decisions about what next steps would be for Thomas. Now you're using a summative assessment also as a formative assessment. So a summative assessment can be a formative assessment. Now, if you are using exit slips, for example, which are slips that teachers give at the end of a class period to see how well students are understanding material, and you never look at them and you never make any changes in your curriculum or your instruction to meet the needs of the students after you've done an exit slip, then that's not formative assessment either. That's just wasted time. Formative assessment is only formative assessment if there is action following that assessment. Some possible ways of doing formative assessment are things like anecdotal records, where you just kind of take notes on the students, interviews, long-term projects, maybe things with a very high DOK, portfolios, graphic organizers, things like that. So let's look at a couple in more detail. One way that we can assess students' mathematical knowledge is by using the math practices that we discussed in the Standards and Progressions video. And in that video, I had promised that I would go ahead and analyze 2 pieces of student work, the ones with the fractions, using the math practice standards. So let's do that now. So here is the first student, and I'm going to go ahead and just call this student A and try to find evidence for each of the math practices. Now, just to let you know, there is a link here in the Google Slides that you can click on that will take you to a copy of the math practices. There will also be a link in the description box for YouTube. Let's read the question to start. Mrs. Wilson has 64 brownies on a plate. 1/2 of her students eat 1 brownie. 1/4 of the students keep 1 brownie for a snack. 1/8 of the students keep 1 brownie to eat at lunch. 8 students keep 1 brownie to take home to eat. Are there any brownies left on Mrs. Wilson's plate? Show all of your mathematical thinking. Okay, so at the end of this question, you were supposed to answer the question, are there any brownies left on the plate? So the answer in here somewhere needs to be yes or no. Otherwise, the student did not answer the question. Also, they need to show all their mathematical thinking. The first mathematical practice is make sense of problems and persevere in solving them. And I do see that the student has made quite an attempt to solve the problem. They did not abandon the task. They don't seem to understand what the problem is asking. And they actually don't see a problem with coming up with 2 different answers, 18 and 26. So that's an issue. They're not making sense of the problem, although they did persevere. The next one is reason abstractly and quantitatively. In this, I don't see any evidence that the student was able to contextualize the problem. Instead of drawing one whole and trying to decide how many parts of that one whole the various brownies or people took, they have drawn 3 wholes as a comparison. So this is an issue right here. I'm a little bit confused about this. Really, this whole thing should be in terms of brownies, but I can kind of see why they were going with students, but ultimately we're talking about brownies. And another thing that if you notice here, here's half, here's a fourth, and here is, well, she's got 8 brownies here? I'm not sure. When you look at what she has shaded, she should have been able to see that this is more than a whole. So this could just be the way that she's decided to draw it. I mean, these are beautiful circles, and she did a very nice job trying to divide them up. But just at a glance, she should have seen that these diagrams could not be plausible. The next practice is construct a viable argument and critique the reasoning of others. So she does have a plan, and she does attempt to discuss her reasoning with the reader. So she's able to do it. She's moving along with that, albeit not correctly, but she is making an effort. Is she able to model with mathematics? Well, she does understand that these circles could be related to fractions, but she uses 3 wholes instead of 1. So there are a lot of misconceptions here. Does she use appropriate tools strategically? You could argue that her circles here are a tool, that she meant for them to be a visual aid, but again, she's using 3 instead of 1. So it kind of all goes back to making sense of problems the first mathematical practice, if she can't make sense of the problem, it's all converging. This is just over and over we're seeing she's not making sense of the problems. She's not making sense of the problems. So this would be how I would differentiate for the student. I would go back and look to see if I could get her some practice and some additional, like a reteach or additional instructional time or a brand new lesson on how to understand what's happening and how to use the POIA strategies effectively. Because she's not afraid of using strategies. She's doing a great job with that. The problem is not being able to make sense of the problem. The next practice is attend to precision. She does do things that make it very nice. She's using the horizontal bars for fractions, which is a preferred way of showing it. By the way, if you see students using the diagonal bars, that's very fancy, that's very nice, but it is much easier to keep track of things when you're using this horizontal bar. So I would give the student a lot of kudos for, being thoughtful about how they're representing things. She has a little bit of problems with the units. She's kind of a little bit confusing brownies and students. So like, here's 8 students, cut brownies, or eat brownies. I'm not sure what that says. There's room for her to grow. She does have some things that are really working good for her, but she does have certainly some room to grow. The next part is look for and make use of structure. The student organized her work, certainly. She was looking to make sense of it, but she didn't really have a firm understanding of how these numbers were related. So she's getting to a point, in my opinion, looking at this work, if she had more of an idea of what the problem was asking, she might have been able to put more pieces together. Her big gap is not understanding the question. The last practice is look for and express regularity in repeated reasoning. I mean, she has a systematic way of setting things up, but since her logic was faulty from the beginning, she didn't get very far. What I really like about this example is that it all tends to converge to that very first mathematical practice, that she wasn't making sense of the problem. Ultimately, she should have had an answer that said, yes, there's brownies left, or no, there's not any brownies left, and explain why she thinks so. Here she got 2 numbers as her answer. She's got 3 holes. I mean, there's a lot to work with. So that would be my first step for her. So in assessing this, I would say that there is the least amount of evidence that she's able to make sense of problems, but she is able to persevere. So that's a great thing to have. She's not going to abandon the task. She's comfortable using tools. She just needs some clarification on how certain tools work, maybe. She's on her way to attending for precision. She does try and try again. And yeah, that's what I would do. I would look for that to differentiate and then assess her again. Let's look at the next one. Okay, this is student B. Let's see what she does. It's the same question about the brownies, and let's start by looking at the very first math practice. First one is make sense of problems and persevere in solving them. As we recall, the answer had to say, yes, there's brownies left, or no, there aren't any brownies left, and then the student had to show their mathematical thinking. And here I see that she has made a decision that there are no brownies left, and I will let you know that this is the correct answer. There are no brownies left. The student actually had the correct mathematical thinking throughout. So here it said 1/2 of her students eat 1 brownie. Here's 1/2 of the students. 1/4 of the students keep 1 brownie for a snack. So this is the part that has the brownies for a snack. 8 students keep 1 brownie to take home to eat. Here's the 8 students to take home to eat, or for lunch and to eat. Let's see where she started. There are no brownies left because when I made the circle graph, I figured that 1/2 students, 1/4 students, 8 students, and 8 students. Since 8 students' side is equal to 1/8 students, I figured 8 equals 1/8. I would make 1/4 16, and then she stops. Maybe there's more on some other page. But she is correct that all her mathematical thinking is correct, and she got the right answer. So Here, the student did answer the problem completely, and her work is presented very easy for the reader to find the work. The next, practice reason abstractly and quantitatively. So the student was able to conceptualize the problem. She only used one whole instead of more than one whole to figure this out. She also does work using abstract right here. So she's showing all her work in all these various ways. Construct a viable argument and critique the reasoning of others. Well, she showed a clear plan on how she came up with this, and she did it a variety of ways. She could have included some of the work underneath each one of these pieces just to make it a little bit easier to follow, but I'm just nitpicking at this point. Her use of vocabulary is okay. I would have liked to have seen words like fraction, remaining, equivalent, but again, I'm just being very picky at this point. Modeling with mathematics, the student uses the whole circle. We already discussed that. One thing that I would say is she made a circle, which seems to be like the default way of students thinking of fractions. If I were going to push this student, I would try to push her towards maybe the set model for fractions or a rectangle, so that she could also show her ideas with something else besides a circle. But again, I'm just being super, super picky. She does use the tools. Like I said, I would consider the fraction or the circle representation to be a tool, and she does use it appropriately. Okay, so for attending to precision, she labels everything neatly. She's using the correct fractions. She's using the correct units. Again, they're kind of using the brownies and the students. Like student A also kind of used the students and the brownies. If I were going to rewrite this question, I think I might have just kept one unit or the other, because I think it can make it a little bit confusing for students there. The fractional bars, she is attending to precision and using the fractional bars horizontally, so that's great. One thing I have noticed is that the student didn't really try to go for a common denominator. Although she seems to understand that common denominators make things easier to add, she didn't necessarily look for the common denominator that was 64. Yeah, she never talks about a common denominator in her explanation. I will say that she did work with proportional relationships here off to the side. She's working towards that other standard, but that's not part of the standard that's being assessed here, nor do I believe that it's a 5th grade standard. So I would say that she has clearly met all the math practices in this work. There is always room for improvement. I'm just one of those teachers that are always looking to try to make students better. So if they're hitting that bar, then I raise the bar and make them grab for it. So those are the kind of things that I would work with the students. For this student, maybe try to increase her understanding of abstract and quantitative reasoning and working with vocabulary. So that's how I would use her assessment in a formative way to figure out how I'm going to differentiate. Now, as a reminder, here is the link. This is going to take you to the same information that's in the previous slide. It also has a blank grid that you can use for your own work. Another great observational tool, which frankly, I was never good at doing this. I was never this organized, but I wish you luck, is taking down anecdotal records for your students. So as your students are working, have a clipboard with cards on it, or make yourself an observation rubric so that you can kind of jot down names where different students are. The nice thing about this is that when you have parent-teacher conferences, you can take out your observation tools and then actually speak to the parent about what you're seeing your student do in math class. So these are really great. Don't try to keep anecdotal records in your mind. You have too many students and too many subjects to do that. Find a really easy way to take just 1 or 2 words to describe what a student is doing. Or this idea of an observation rubric, this is very aligned with universal design for learning. You're anticipating ahead of time what are the various indicators of how a student might be performing in class, and you're starting to separate the students into those various groups so that you can start to differentiate for them. You can come up with activities that are going to be enriching, but you've thought about it ahead of time. It's a more of a proactive approach. Diagnostic interviews are awesome. They take a long time to do. They might even take longer than like running records, which if you've ever taught reading to a whole group, those of you who have understand that running records take a really long time, but they're essential. Diagnostic interviews are going to take just as long, and I don't recommend that you do them as often as running records. But one thing you might want to think about is maybe doing a diagnostic interview once a year with a student, seeing how they're doing in math class. It's almost like a mixed methods study where you're taking in observations, you're looking to see how the students are engaging with the problem and questions they may have, just one-on-one, you and them, and then comparing it with any quantitative information that you might have gathered through other assessments. I'm going to go ahead and ask you to pause here, and I have a video that I want you to click to. As always, you can access that video by clicking on the Google slide, or that video will be in the description box below, so you can stop and watch it there. And it will also be in the weekly module section of Blackboard. The person that you will be watching is named Marilyn Burns. Her work is so well known in academic circles and also in just regular districts. She's really fabulous. And what you're going to see is just her working with students to get an idea of how they're thinking so that she can get a better understanding of how she can support students or where misunderstandings might exist. In addition to this video, I'm also going to link an article in the description box and also in our weekly module that will allow you to read a few more scenarios. This article is not part of the class. It is completely optional, but if you like what you saw with Marilyn Burns, I'd really encourage you to read it. It's a very light read. Okay, so go ahead and pause the video here, and I will meet you after you watch the Marilyn Burns clip. The last type of assessments that I'm going to discuss are performance assessments. And it can also be called an alternative assessment. They're embedded tasks that are similar to those that a professional might do in their job. They're usually very hands-on. And because we already talked about differentiation and we talked about DOK, this is likely to be a DOK 3 or 4 task. Could very well be a 3 or 4 task. Giving a couple DOK 3, one DOK 4 during the school year. If it's done well, that's plenty, right? It's better to have really solid tasks that fully meet the conditions of a performance assessment than just to have a bunch of random things that really aren't connected and not very well planned out. Performance assessments are really nice because they can draw from a number of things that appeal to students. They can incorporate choice. They can use various types of learning styles. They can use a variety of materials. The thing about performance assessments is that they can be very subjective. So a rubric, for example, for something like a performance assessment is really necessary so that you can maintain some level of reliability from student to student. Okay, and to minimize bias that we all have in some way or another. So really keeping track of what is it that you want the student to do, what does good work look like, do the students all have equal access to these materials, what are the time frames, do the students have a full inventory of skills that they need in order to complete this, how authentic is the task. All those things are really good to know. One thing that I'm going to link into the description box as well is a folder that will take you to a number of performance tasks that the DOE created. A lot of them are already leveled with DOK, so that makes it really, really nice. So you also have some resources here that you can look at and be able to perhaps just turnkey into your class. So these are really nice to look at too. That kind of brings us to the end of today's lecture. I hope you guys have a great rest of your day. I will get to talk to you again in the next lecture. Bye!